So why should we be using two-tailed test? Well, we want to be rigorous and keep an open mind when we analyze data and evidence. So we should use a one-sided hypothesis only if you truly have an interest in only one direction. And so unless you have a specific reason otherwise, go with two-sided hypothesis. And if you've chosen a two-sided hypothesis test, it's never okay to go back to one-sided after observing the data. For example, suppose we're interested in finding any difference from zero, which is a two-sided question. We've created a smooth-looking null distribution you see on the screen, presenting differences due to chance. What would be the p-value under a two-sided hypothesis, where the difference is not equal to zero? Well, in this case, we would add up both tails and we get 8%. 0.04 times 2 is 0.08. So we would have failed to reject. On the other hand, what would be the p-value if we switched to a one-sided hypothesis, where the difference is, say, greater than zero? If we went greater than zero, that's just the right tail. The p-value is just at 4%. So if you notice, the two-sided test I would have failed to reject, would say there's no difference. The one-tailed test I would have rejected and said the difference was greater than zero. That would have been a type 1 error. So notice in the two-sided case, we would have failed to reject the null hypothesis, while in the one-sided case, we would have rejected it. So type 1 error or false positive. After observing the data, it is tempting to turn a two-sided test into one-sided. Try to avoid this temptation. Hypotheses should be set up before observing the data.